using supercomputers, and yes, supercomputers have gotten better and better and better, but running them at higher and higher resolutions costs more and more compute power.
Mm.
So a lot of the time, the weather app in your phone is fed these more large scale weather models where, yeah, you don't have the information change between where you are and 3 kilometers away. So that's in the United States, we do have a high resolution model that runs at 3 kilometers that's updated every hour.
Yeah.
But imagine, and the one step we've taken with Focus is that we've actually moved, we update it as fast as we have observations. And one of the observations that we have regularly in the United States is satellite imagery, which you can think of if you're sitting on the International Space Station and taking pictures with your phone. It's similar to that, but these geostationary satellites are actually much further away,
Mm.
so that as the Earth turns, the satellite stays with the Earth. It's at a Lagrange point. That's what it's called.
Oh, wow.
So the geostationary, you can sit back there and take pictures all day, and actually it takes pictures every 5 minutes over the U.S. And then to complement those pictures, so we can know where clouds are, we can use our radar network in the United States as well, where we have these big golf balls. If you've seen them near airports, they're on a 10-meter tall tower. You'll see this
Yes.
big white golf ball there.
Yeah.
Underneath there, there's actually a 10-meter dish. So it's a huge DirecTV dish under there that spins and takes radar measurements around the United States globally. So we can stitch those together with the geostationary obs. So we can say, hey, we definitely know there's a storm here. Let's feed it into our AI weather forecast model to make sure it knows correctly where the storms are, and it can then propagate them forward. The
Huh.
big in weather forecasting, they're called initial value problems. So
Mm.
initial value problems, you need to know where the weather is currently to know where the
Mhm.
weather will go. Same
Yeah.
thing with, like, if you're at home plate playing baseball, you
Yeah.
need to know where the baseball starts, and by the time you blink, it's moved, but your brain knows kind of where it's moving,
Yeah.
unless you're
You have an
facing an
assumption.
amazing, yeah,
Yeah.
unless you're an amazing pitcher that's throwing the curveball, you can't anticipate it, right?
Yeah.
But it's the same
Definitely.
idea. You need to know where the weather is currently before you can move it. And if you have an error on where the weather is currently, then you're going to have an error where it will go. So if you
Mm.
constantly update these weather forecasts quickly, you're reducing the errors of misplacements of where storms are. And the idea is then hopefully that you get the correct placement, and then the forecast will be more accurate after that.